Welcome back to 9.3. I believe this is the third video of Chapter 9. We're kicking off here this video with circles on page 6 in your notes. And talking about some vocabulary here about circles. D. Okay, so this D down here is going to represent the diameter. The diameter of a circle, that is a line that goes from edge to edge and passes through the center. Okay, so this line here is the diameter. Center of the circle, edge to edge. Radius, that's what R is. A radius is basically half of a diameter from, in other words, it's the center of the circle out to the edge of the circle. And there's obviously can be infinite number of radius or diameters through a circle. So since I know that, I can basically say that a diameter is equal to 2 radius. So that's diameter is equal to 2 radius, 2 times radius. So if I gave you the value of a radius, you could multiply by 2 and have the diameter. Or vice versa, you could take the radius and you could cut it in half, as you can see right here. Or you could cut the diameter in half, all right, and you'd have a radius and a radius here. So 2 radius make 1 diameter. Okay, 2 times radius is equal to d, or radius is equal to d divided by 2. All right, well, the circumference of a circle is basically the distance around. Okay, and we call that perimeter. The formula for the circumference is, let's see, oh, that didn't come up, I'm sorry, is 2 times pi times r. Now, what is pi? Pi is a value that's approximately 3.14, and it goes on for, it's actually called an irrational number. It repeats, it doesn't repeat, it goes on forever and ever with no repeating pattern. Why is it important to us? It basically has to do with the relationship between a diameter and the circumference. Okay, if you took the length of this diameter and you stretched it around the circle, it would take 1, 2, 3, and a little more than 3 diameters. Take a little more. It would have 1, 2, 3, and then this distance right here would be like 0.14. So you would need a little more than 3 diameters to go all the way around to equal a circumference. Okay, so that is, it's very important to us, that number 3.14159, and on it goes for us. So to find the circumference, if you know the radius, you can multiply it times 2 times pi. It would give you the length, or you could just multiply the diameter times pi, okay, because it takes this many diameters to get around for the circumference. So diameter times pi, or 2 pi r, is equal to a circumference. Let's look at this sheet here for a moment, and you can see it right here. You'll have this with you on the test, so you don't have to memorize that, but it's something you probably should know because you will need it for later classes, math classes that you take there. So, okay, moving on to this particular problem, which is, I believe, on page 7 in your notes. This is an example, a sample for you to find the circumference of this particular problem. So we have a radius of 70 here. If I were going to find that, so we're going to use 3.14 for pi. We generally always will. There is a fractional value that they use 22/7, but typically we use 3.14. It's a rounded off value for pi. It just makes things a little bit easier for us. So if I know that the radius is 70 inches in this particular question, you take 2 times pi times 70, and you just put that in your calculator. Put that in, you get 439.6 inches. Notice it's not inches squared because the circumference is a linear measure. It's not two-dimensional. So it's just inches. That's how many inches would go around the circle in this particular problem. There. So yeah, it's pretty simple once you know that formula. And then the formula for the area is, we're going to use that pi value again, pi times the radius squared. Okay, pi times the radius squared. So if you know the radius, all right, you would square that value, multiply it times by itself, and then multiply that times pi for you. So hopefully that makes sense for you. And again, that's on your yellow sheet down there in the circle apart. So let's do one together here. If we have this circle, this will be a fairly big circle actually, a little over 2 meter radius. All right, again, the formula was pi r squared. Okay, well, let's work that out. Okay, there's pi, 3.14, and the r squared, looks in my PowerPoint, I went ahead and multiplied it out. There is a calculator button where you can put in 2.1 and hit the x to the power of 2, and it would compute that for you. Anyway, excuse me, it came out to be 13.85 square meters, or, you know, the way we usually write it, like I have in the other ones, just be meters squared like that. But we say square meters is better. It's more proper way to say that for you. And then, yeah, that should take care of the circles for you. And then we roll on into volume on bottom of page 8 here for you. When we talk about volume now, we're talking about filling a three-dimensional object. Okay, so I tried to draw a picture here of, let's imagine that's a box, and you're trying to fill that box with cubes, because a cube now is what we're going to use to measure it, because a cube would make sense because a cube has equal side lengths. So we're just trying to figure out how many cubes would fill an object if we have a cup, okay, and we wanted to see how much space is in the cup here. We would be measuring to find the volume of this, the number of cubes that would fill this perfectly. Okay, it doesn't matter what the object is. We have different ways to do it for different objects, but it begins with understanding we're talking about using unit cubes to fill the object. Okay, so it's the number of unit cubes that would fill an object. Again, it has to be a cube because we're talking now about a three-dimensional space. There. So a volume for a rectangular solid is pretty simple, really. All you need to do is multiply the length by the width by the height, and you'd have it here. So if we look at a problem like these two, pretty simple questions actually. Number one, if you're going to find the volume of that, you're just multiplying 4 times 5 times 8, and it would come out to be 160 inches. But notice my label is cubed now. It's the power of 3, because again, we're talking about using little cubes to measure the space inside this object. Okay, if we did the same thing for number 2, you get 45 feet cubed there. So simple enough for you. Let's take a look at the formula sheet to make sure we are on the right page here. And it looks like the volume stuff starts over on the right hand side right there. So there it is. There is the information on the rectangular solid right there. Length, width, height, volume, you multiply the 3 there for you. So hopefully that works out for you. Let me get back to my PowerPoint now. And then if we talk about a cylinder is a real interesting object. It's basically like your traditional pop can, not perfectly, but if it were a little squared off on the edges, that would be a cylinder. What you want to do here is the way to understand a cylinder is to realize what it is made up of. Basically, you have a circle right here. Okay, you have a circle, and you have a circle on the bottom that are the exact same size. So if you can figure out the area of that circle, of one of the circles, this measure right here tells you how many of those circles that you have. So in this particular circle, you have 12. Or in this cylinder, you have 12 of these circles stacked up. So if you can find the area of one of the circles, you just multiply it by the height, because it would stack it up. So basically, this is what I've just said. The volume of the cylinder is the base area times the height. Okay, base area, whoops, I went a little ahead there, times height. So the base area of a circle is pi r squared times height. And then here I plugged in the values for this problem. There's pi, there's r squared, and there's my height, 12. So you're just going to multiply those numbers together, just like that, and you come up with 602 and 8800 centimeters cubed. Again, it's cubed because, again, even though it's this odd rounded object, you are using a unit measure of cubes that would fill up this particular object for you. So I'll pause it here because we're nearing the end of our time, and I will pick it up with the next. I think I've got another cylinder question coming up here. Yep, bottom of page 10. We'll start there when we come back.